In this second lecture of special relativity, we defined what are inertial frames and stated the principle of relativity. As we have seen in the previous lecture, a physical process, like the equation of motion of a moving object, can be described in any reference frame. However, inertial frames, that is, frame where the motion of a body not subjected to forces is uniform, are usually preferable. The first example we considered is the one of a moving ball having constant velocity. Here the frame chosen is an inertial frame. The second example we considered regards a mass oscillating due to the presence of a spring. Even though the mass accelerates in the reference frame chosen, because its force coincides with Hooke's laws, the frame is inertial. The third example we considered regards a balloon left by a child on a carousel. The parents, who are not on the carousel, watch the balloon floating still. The reference frame is inertial. The child, who stands on the carousel that is rotating for simplicity at a constant speed, sees the balloons accelerating even though no forces act on the balloon. The child's frame is not inertial. We discussed the meaning of fictitious forces, that is, apparent forces that may appear when studying a physical process in a non-inertial frame. We then stated the principle of relativity that says that the laws of physics must be the same in all inertial frames. We also made the remark that this is valid up to special relativity, and that general relativity, that is not the topic of this course, extends the validity of the principle to all frames. We used the gravitational force between the Earth and the Moon to present examples of the principle of relativity. The force is indeed the same if two reference frames are spatially translated, once with respect to the other. The force turns out to be the same even if the two reference frames are time translated, once with respect to the other. That is, they measure times with non-synchronized clocks. Finally, the force results to be the same even if a reference frame moves with constant velocity with respect to another, that is, under velocity or Galilean boost.